Hello guys, welcome back to my channel Algorithm Mind. My name is Hassan Khurram and in this channel I teach programming skills in MATLAB, Python and R programming. I also teach theoretical concept as well as practical programming skills in data science, data analysis. So if you want to learn programming from scratch, I request you to subscribe to my channel and hit the notification bell icon button. So I have been producing a series of tutorial videos regarding statics with Python and as well as marketing analytics case study. So in today's tutorial, I'm going to discuss with you and I'm going to teach you how you can actually conduct ANOVA analysis with Python. And we will basically look at a marketing analytics case study where we will have a marketing data set, and based on that marketing data set, we will conduct our ANOVA analysis. And I will teach you how you can actually conduct your own ANOVA analysis with Python here. So it will be a bit of theoretical section as well, and with a lot of practical programming skills that you can learn from this tutorial. So that being said, so what is ANOVA analysis itself? So analysis of variance or ANOVA is a statistical test used to assess the difference between the means of more than two groups. At its core, ANOVA allows you to simultaneously compare arithmetic means across groups, which you can determine whether the difference observed are due to random chance or if they reflect genuine, meaningful differences. So in ANOVA analysis, we have independent variables and we have dependent variable. The dependent variable is a variable of study, or we are variable which we want to say. For example, marketing data set has a profit column, and we say that what are the parameters that are dependent on which parameters the profit is being dependent on. So we say that the profit might be dependent on the marketing channel that customer acquired. It could be dependent on the holiday season as well. So that being said, we want to study the impact of one variable that has on other variable, and we can successfully do that with the help of ANOVA analysis. Now you know the understanding of ANOVA analysis. Let's move on and actually jump to our practical programming section. The first thing we need to do, we are going to import important libraries for our data science case study. The first library I'm going to import is called pandas. And using import pandas as PT. Then I'm also importing a stats module API as SM. And finally, from stats module formula.api, I'm importing OLS. So these are the three important libraries, stats models and pandas. Okay. So after loading this library, let us briefly discuss about our data set. So our data set contains columns such as customer ID, their gender, their date of birth, their location, their registration date, marketing channel type, how the customer was acquired, whether the customer was acquired through organic search, whether the customer was acquired through paid advertising. So that distinguish category of that specific customer. Then we have like first order profit. What was the profit that was earned from the customer by his first order? Then we have subsequent order profit. Obviously, some customer would like to purchase from the same brand again and again. So in that case, what is the subsequent order profit from that unique customer? Then we also have our customer order counts and total value of all promotions. So what is the total discount that was given to a customer in order to convert him to a loyal customer? So basically it means that what are the different discounts that the customer was given in order to, so that he can actually buy more from the business. Then we have age of customer, and finally our variable of study, total profit that was generated by that specific customer. Okay, so that's a marketing data set we have. So the first thing we are going to do, we are going to import our data set, which is present in a CSV file format. So first of all, I'm going to declare the file name by using this Python statement, initializing a variable name Excel file and assigning it to a value of string df_comma.csv. After that, I'm going to initialize a variable named marketing data, and I'm going to equate its value by calling the function panda_csv. So panda.read_csv, it will read the CSV files. Let me just run this block of code for you. Now, after the data has been imported, let us briefly look at the data set by using head method. Now you can see that we have customer IDs that are unique. Then we have the customer gender, whether the customer was male, female, and we have date of birth, location, allowed contact. Then we have marketing channel type, or based on what marketing effort or a business has put to in order to acquire that customer. For example, for row 1, the customer was acquired by organic search, and for row 2, the customer was acquired by affiliate marketing. And then we have first order profit, subsequent order profit, then we have subsequent order counts, and total value of all promotions that was being offered to a customer as a part of being discounted offers, so the customer can avail that discounted offer, and in turn that will ultimately increase the sales for a business. Then we have total profit, which is our variable study. We want to see what variables do impact this total profit. So that is the essence of what we are actually doing the ANOVA analysis. Now, after loading the data set, let's just briefly look at our data set by using df or marketing data.info method. So here we can see the column names, and we can also see their column data type. Then finally, let's move on and actually see some statistical aspect of our data set. We want to see what is the minimum value, what is the maximum value, how the data is distributed between quartiles, what is the 50th percent quartile, 75th percent quartile. So that being said, okay, so that is, and what we can see here, we have first order profit and count. So okay, so the maximum number of units that were acquired by customers was 32. So the customer has ordered 32 times from the same brand. That being said, so let's separately rename our variable of interest, which is total profit. So we are here creating a data frame Y, and we are taking values only for the column total profit by using this Python statement. Now we are to see what are the independent variables that will ultimately affect this total profit. So there are 3 variables that we are going to study right now. So we will have to study the effect of these 3 variables on total profit. So we have gender, which is again a categorical data. We have location, which is again a categorical data, and we also have marketing channel type, which is also a categorical data. Now, in order to use that data for ANOVA analysis, what we actually need to do, we need to convert that data into categorical type, and that is quite easy to do. We are simply going to initialize, we are simply here in this Python statement, the first Python statement, you can see we are updating the current values of column gender, and we are converting the data type of that column into category by using this method here as type category. So that's it. That by doing that, we are able to convert that data into categorical data. And we will do the same thing for location, and we will do the same thing for marketing channel type. So you can see that. Okay, now that being done, now we are going to conduct ANOVA analysis. So, and we are going to use three-way ANOVA analysis. Three-way ANOVA analysis, it means that we are actually studying the impact of 3 variables on total profit. So that's why it's called three-way ANOVA analysis. Now we are going using this Python statement here. We are initializing, first we are initializing a name model 1, and we are equating its value. Then we are calling the OLS method, and we are passing string and our data set. Okay, so basically we are passing 2 input arguments. The first one is actually in the form of string, and the second input argument is our data frame or marketing data. And then finally we are going to fit that model to our OLS. Okay, so here we are the first variable will be the variable of study when you are defining that string, and then we use negating sign here, and then we pass the variables that will ultimately affect this total profit. So here we have 3 variables: gender, location, and marketing channel types. We keep that in mind. They are being defined by this notation where we write C then within the round brackets we write gender. So C stands for categorical data. So that's it. Okay, so you will write the variable of study total profit, then you use a negating sign, and then you will define the variable that will affect the total profit. And if they are categorical variable, we will use this notation C round bracket gender round bracket cloth. Okay, and the same goes for location and marketing channel type. So what does this OLS stands for? OLS stands for ordinary least squares, which is the method used in statistics to estimate the parameters of linear regression model. It minimizes the sum of square of the residuals, which is the difference between the observed and predicted value. The string here, total profit, then we have negating mark, and we have C gender, C location, and C marketing channel type is a formula interface. It specifies that you want to model total profit as a function of three categorical variables, which are gender, location, and marketing type. And here C function indicates the variable is actually a categorical variable. This is important because it tells the model to treat this variable as categories rather than continuous variable. Then finally, we are using in this Python statement fit method that is called on the OLS model to estimate the parameters of this model. When you call fit, it performs the following action. It computes the coefficient for each predictor, in this case different level of gender, location, and marketing channel type, and that best fits the observed data according to the least square criteria. And what do we have after performing this after fitting that data to our model fit by using OLS? So we will have a fitted model object that contains various statistical information about the model, including coefficients of the predictors, p-value of hypothesis testing of the coefficients, r-square value of goodness of fit, summary statistics that can be assessed by using the summary method. So we have already fitted our model in the variable model 1, and by using this method summary, we will be able to see all the statistical features like coefficient of predictor, p-value of hypothesis testing, r-square values. Okay, so this is the output of our fitted model. So let me just run this block of code for you, and let me run this. So now you can see the r-square values, you can see the p-values as well, and that degree of freedom and so on. So let me remind you again. So OLS creates an ordinary least square model using the specified formula and data. So specified formula is actually this thing in the string, and the data is the data frame. And fit estimates the parameters of the model and return a fitted model object with detailed statistics. Now that being said, you have a fitted model. Now you can easily conduct an ANOVA analysis by using this Python statement here. For your first initializing a variable named ANOVA underscore table1, when we are creating its value and calling sm.stats.anova underscore lm method, and we are passing two input arguments. The first input argument is actually the fitted model object that we have actually fitted for our data frame, for our formula, and our for data frame. And the second input argument is type is equal to 2, which is actually so I'm going to explain you in a moment. So basically it's a more of how you calculate the sum of error. Okay, that being said, so the ANOVA LM function is the stat model library, is a function used to perform ANOVA analysis on fitted linear model, or OLS, or generalized linear model. It computes the ANOVA table from a fitted model, allowing you to address the effect of one or more factors on the responsible variable, dependent variable. Dependent variable in our case is the total profit. The ANOVA table includes key statistics like sum of square, degree of freedom, f statistics, p-values of each factor and their interactions. So that's the, after like learning this Python statement, we can get the result in the form of this table, which have a number of things that we can actually look at. Okay, so and we are going to discuss that. So the first one is actually sum of square errors, which represents the total sum of square, which represents the total variability explained by each factor. Then we have degree of freedom, that reflects the number of independent pieces of information used to estimate the parameter. Then we have F statics, a ratio of variance estimate, indicates how much of the total variance can be attributed to the factor. Then we have p-value, which indicates whether the factor has statistically significant effect on the dependent variable. In other words, we can, by the help of p-value, we can identify whether these variables or a columns, in our case like gender, location, marketing channel type, has any significant effect on the total profit. So we can identify that with the help of p-values. Now coming back to the second input of this Python statement, in order to conduct ANOVA analysis, we set it type is equal to 2. So what is it actually? This integer parameter specifies the type of ANOVA to perform. The type 1 is actually sequential, where sum of squares are calculated sequentially. The second type 2 is actually marginal. Sum of squares are calculated while accounting for all other factors. And then we have 3, also a marginal, where sum of squares are calculated considering interaction amongst all factors. That being said, we can actually conduct ANOVA analysis with the type 1 and type 3. So that is exactly what I have done here. So we have like we will initialize a variable name ANOVA underscore table underscore type 1. This is a variable name. You can define your own variable name. Then we are calling SM module, and within the SM module we are calling stat.ANOVA method, and we are passing 2 input arguments. The first one is actually the fitted model, and the second input argument is the type or type of ANOVA we actually want to conduct. So we have sequential, so type is equal to 1. Now after doing that, we are successfully able to conclude the result by using this ANOVA table. And let's do for the third type as well. So we are going to do the same thing for third type. So we will write the same Python statement. We will declare initialize a variable name. Then we will equate its value when we are calling SM module, and within the SM module we are calling the method stat.ANOVA and passing 2 input arguments. The first input argument is the fitted model, which is fitted according to the formula we have given to it, and also the data frame. And the second input argument is the type of ANOVA we want to conduct. In this case, we are setting it to 3. Let me just run this block of code for you. Now you know that how to conduct ANOVA analysis with different types, okay, as well. Now, what if the analysis you conduct have a continuous variable in it, and you also want to study its impact on total profit? In our case, age is a continuous variable, it's not a categorical variable, and we want to study its besides other parameters such as marketing channel type, gender, we also want to study the effect of age on total profit. So again, that is quite easy to do. What we are going to do, we are going to use the same Python statement of OLS, and then we pass the formula, then the data frame, and finally we call the fit method. So here there will be a little bit change in the formula, but right now, so we will use the same analogy we have used earlier. So we will write total profit, then this negating marks, then we will define C within round brackets gender, and C within round bracket marketing channel type. Now in order to define a continuous variable, we don't write C or round with round brackets, we simply just write the name of the column that is currently present in the data frame. So once we've done that, we can simply then use this fitted model and conduct an ANOVA analysis. So let me just run this block of code for you. Now you can see that we have successfully conducted an ANOVA analysis. Okay, now final thing, let's discuss about hypothesis testing, which is again the essence of why we are actually conducting the ANOVA analysis, because we want to see the effect of those variables on the response variable, to see whether they have significant impact. Now with the help of p-value, we can actually conduct a hypothesis to see whether it has a significant impact or doesn't have a significant impact. So we are going to use the same Python statement OLS, and we will pass the input argument or formula, then a data frame, and we will call the fit method, and we will use stat.ANOVA method of module sm, or then we pass two input argument. The first input argument is actually the fitting model, and the second input argument is the type of ANOVA you want to conduct. So let me just run this code for you. Now you can see. Okay, now in order to so now you can see that we have our p values, okay, right here. So we will extract the specific p value by using this Python statement. So we are creating a data frame p underscore values, and we are only extracting the column pr round bracket greater than f. That means this last column we are extracting, which has the p values. Now in order to conduct the hypothesis testing, its value should be less than 0.05, which is the alpha in our case. Okay, so here we are simply writing if else statement, and we are checking whether this p value, whether the p value of gender is less than 0.05. If it's less than 0.05, we say that there is a significant effect of gender on total profit. And if it's not greater than less than 0.05, we say that no, there is no significant effect of gender on total profit. And we will do the same thing for age and for marketing channel type. As you can see that I have used if else statement for all of these three variables which were studied in order to find whether these variables had effect on total price. So that being said, when we conduct a ANOVA analysis, and we can see that all three of them have actually a significant impact on total profit, and we can also verify that with the help of this table here. You can see that C gender, C marketing type, and C marketing type and age, they all have p value quite less than 0.05. so that's where means that there is a significant effect of gender on total profit, and there is a significant effect of age and marketing channel on total profit. That's it for this tutorial. I hope this tutorial have been helpful. If you have any question regarding today's tutorial regarding ANOVA analysis or even the statistical analysis with Python, I request you to write down your comments. I will be happy to help you out. I will be publishing more tutorial videos on marketing analytics case study, where I will implement a whole data analysis for marketing business. And with that thing, I will also publish tutorials on Tableau and R. So I request you to subscribe to my channel and hit the notification bell icon button so you can get the notification as soon as I publish the video. Thank you for joining me, and I will see you soon in the next video.